Hey guys, Meteorologist Lindsey Slater here. Yes, that show did happen for a lot of Southeast Wisconsin. So I want to talk about your space weather here. Our solar cycle, we're in the declining or descending phase of that cycle. So we're sitting right about here. Now it has kind of evened out a little bit, but we'll likely continue to see that descension as we go into the next few years. And then it's going to pick back up as we head into about like the 2035. It's an 11-year cycle. So we're in the descending phase, and the descending phase can give us a lot of really great shows. What's happening is the sun itself is those sunspots are migrating towards center, basically like the sun's equator. And eventually the polarity of the sun flips every 11 years, which is why we have a cycle. So when we see those shifts, it just gets very chaotic and it shoots out all these plasma and it shoots out solar flares. We get solar energetic particle events. We get a lot of stuff going on when it comes to our sun. So this is a look at LASCO, and you see how it kind of looks like a snow globe. This is because on the 11th, on Veterans Day, very early in the morning, we got a big X flare that was in combination with plasma, a CME coming out of it as well. Remember, flares are what produce radio blackouts, and they are instant. So the minute you have a flare, you get the blackout because it is literally instantaneous. That does not cause coronal mass ejections. That does not cause auroras. What causes those are plasma coming out of the sun. So that plasma came out of the sun, and then we had all of this. This is solar energetic particles came out of the sun. So we also then had a solar energetic particle event, which is why if you go on SWPC's Space Weather Prediction Center's homepage, we had an S3, a strong solar radiation storm. This is, again, those solar energetic particles. So this is mainly going to be impacting flights, passengers, polar regions, seeing some of that. G is when you have the plasma. This is when you have the potential of aurora. But a more bigger story is this kind of stuff can impact transformers. It can impact radio frequencies, especially during severe weather. Sometimes we get these events in combination with severe weather. They're not tied together, but if that happens, you can lose your satellite and then you lose communication. So what we are looking at now is the predicted is G4 along with G3 storming for the next couple of days. This is because of that big X flare, or not because of the flare, but because we had this. And I talked about this on 12 News at 11 yesterday about these 3 CMEs that came out of the sun, and they are absolutely Earth directed. We can see them right here. So the bigger show technically should be tonight because it was a bigger blast that came out of the sun. So that is what we're watching. That's my coronagraph there. You can see the magnetometers were all over the place. It measures fluctuations in the magnetic field of Earth. And if the Earth is fluctuating, the magnetic field is vibrating, it's primed for the electrons to get fired up. And when you have an event preceding a larger one, it can kind of get things primed and ready to go. It's like the equivalent of stretching your muscles before you're about to do a workout or something. It kind of gets things ready to perform well. And you can see the proton flux really went up. Again, this is that is the solar energetic particles. So this would alert. This is a warning threshold for polar airplanes. I believe if I go to DRAP, we'll be able to see some of those particles. We'll be able to see, yep. So this is very, very indicative of a solar energetic particle event. You're going to see on both sides basically just red. This is where you get that impacts. And honestly, even northern Wisconsin and parts of like Maine and stuff are in that window, which basically just means that you have a likelihood of having more radiation problems. Not a good time to send out astronauts right now. So that's pretty wild. You can see if we go to the poles, you can see that definitely at the poles, and then the different levels of radiation going up in megahertz. So it's pretty wild. No more flaring because, again, flaring happens instantaneously. And this is the angstroms we look at. 131 angstroms is the frequency we look at to see solar flares. And so there's a little bit of action going on right there. You can kind of see that here. There's some little flares and there's a little action here. We can go to 195, maybe 171. Yeah, we can see some, the Earth is still, this is a huge section right here. Wow. There's a lot happening there. So that's something that we're definitely going to keep an eye on. But let's talk about our Aurora's chances. And here is what we're looking for. This is why I can usually only give you a 3-hour window. And I want to give a shout out to the folks I'm on the Discord channels for geomagnetic storms, auroras, solar flares. solar energetic particle events, even terrestrial weather. We're all in this big community so that people who are much smarter than me, who understand this a lot more, have made it their life's work to study this, are helping me get information out to you when it comes to this stuff. I've only been studying space weather for the last year, so year and a half. So, and I do have my space weather certificate from Millersville University. So I understand what all this stuff is. But last night, see the time here? So we had a little bump in action right here. There's a little bump here. What we're basically looking at is the white line is like storming. So when an energetic particle, when a CME rather gets launched from the sun, it flies towards wherever. It could be Mars, could be Mercury, but in this case, we know it was flying towards Earth. So it interacts with our magnetic field. It starts to wiggle it. And this is a look at different indicators that help us. We have density of that plasma. We have the speed. We have the temperature. This all gives us an idea as to what maybe or could be happening with that. So it hits certain areas. So this one is ACE and Discover. These are two areas, two satellites basically before they hit Earth, so that we know that what we're going to see is going to impact Earth. So this CME has to hit those areas. We get all of this data, then we can make a prediction when it impacts Earth, because these are the ways we get the monitors basically. So it's kind of like a radar. If I don't see something on my radar, I can't give you a heads up about weather coming, right? This is the same thing. So these CMEs hit these stations, and then I can give you about a 3-hour, maybe a 2-hour heads up on auroras. Just because a CME is launched and it's heading towards Earth does not mean you automatically get auroras. The magnetic field also has to be the right orientation, and how we measure that is BZ, which is right here. You see that BZ? I'm going to zoom in this map. You want a southern, so see that 0? You want a southern directed BZ, and right around, and I remember freaking out about this because I saw in real time our BZ going from pretty stagnant to boom, it dropped into the minus 50. Oh my gosh, nanoteslas. I mean, that's some pretty big storming, guys. It really is. So, and then it maintained this negative polarity for a long time. So this started likely around, let's see, 21Z is 3 p.m. So that's 3 p.m., 4, 5. It's about 5:30, 6 o'clock. And at that time, that's when I was texting Mark Baden, like, hey, I think this is happening for us. We were a little cloudy, but this is kind of what we were looking for. This is what I was waiting for. And then I said, okay, look for pictures. I kept asking people, hey, if you're in Walworth County, if you're in Jefferson County, if you're in Kenosha, if the cloud's clear, you're going to see this aurora. And yeah, we had this storming all the way until about, it looks like 10 p.m. A little bit of a break, a little moment there where it went north again. So it's kind of like two magnets. And if they are opposite polarities, they're going to do this, right? But if they're the same, if they're the right orientation, they're going to come together. And that is what a negative BZ, a southern BZ does. It connects those magnetic fields. And if it's going north, it does this. So it's not connecting. You're not going to get a show. You're not going to get lighting up electrons from that CME to create these beautiful auroras. So that was up in the north for about an hour. Then it started trending back down right around, about, leading into the overnight hours. We now are looking at, 3Z, that's about 9 p.m. So we were kind of dancing back and forth of seeing it, not seeing it, seeing it, not seeing it. And then there were a few hours here, here's midnight, where we didn't see much, and then it started trending back BZ negative. Not particularly huge, which is probably why we could only see it with our cameras. The intensity has dropped quite a bit. But this stuff, you totally didn't even need to use your camera. You could have seen that with your naked eye. So that is what I'm waiting for. That is what I'm looking for. K-index can help us with that as well. This is a look at 3-hour data of average K indices. This also just talks about, it's not an aurora chart. What the K-index does is it tells us how disturbed the magnetic field is. That's it. So you could have a high K-index, but if you have the wrong polarity, you're not going to get cool auroras. So that is the meat and potatoes on how this works, what I'm looking for. There's a lot more indices that I can look at as well, as you can see here, but I don't want to bore you with all of that. But if we just look at the last 6 hours, we can see a lot of that, the southern BZ, and then it did shift back north, and that's why we're not seeing auroras right now. So we have yet to get the other one. The other one I think is going to arrive around noon today, which I realize that is during the day. If we can maintain a negative BZ, a southern polarity field, and we can maintain that through evening and overnight, we do have another chance with a bigger amount of energy that could impact that magnetic field to give us this dancing aurora. So I want to thank again people in advance for letting me see your pictures. I've been showing them on air. Yes, we have another chance tonight. Stay tuned to my social media accounts. I will update you guys as we go throughout the day. I'll let you know when the CME is hitting, and I'll let you know when it likely will be arriving at Earth.